Okay, let's get started with this question. This is fairly straightforward, but I like to go over this because it reminds us to consider the observer when we look at problems such as this one. This one is asking us, this is a plane mirror, and it's just asking us how large it needs to be in order for a person to see their entire image reflected. So we're going to take that to mean everything from the top of their head to their feet down there. And all this is about really is following the law of reflection, but I wanted to diagram that out for you. So, what's important here is to remember that when a person sees themselves in the mirror, they're using their eyes, right? Eyes are the detectors in that case. So, that's where the information needs to get to. And these are really photons that are getting there, but we need to follow the path of that light. So I can start by like saying that, okay, this person needs to see their feet. So what does that mean? That means that we need light to travel from their feet to the mirror and from the mirror to their eyes, right? So we're talking about light traveling this way here, bouncing off the mirror. And that light would be following the law of reflection. So I could put in my surface normal here and know that these two angles here were going to be the same, right? Following the law of reflection. Great. So you see already that sort of gives us a lower boundary for the size of that mirror. And now let's think about the other side of the person that they want to be able to see up to the top of their head as well, right? So this is a much smaller angle I'm going to have to put in here, and I'm just doing this by hand, so it's not going to be very exact, but it gives you an idea. Um, and this is about the fact that, right, our detectors, the eyes are really close to one of the boundaries. They're close to the top of the head. They're not located right in the middle of the body, so we don't have that symmetry there. But if I want to see the top of my head, I need to basically go through the same argument here, going from the top of my head, bouncing off the mirror, much smaller angle, and then going into my eye there. So that, let's try drawing that again, that second line, so that it sort of looks like it's bouncing from there. So from the top of the head back into the eye. And again, that would also be following law of reflection. I'm not going to attempt to try to draw that angle in there. It's much, much smaller, but it gives you an idea. And then to answer the question, right, the answer is that, well, the mirror then really only needs to be this big, and that equates to about half the height of the person. So a lot of times people will, when they first see this question, will think about the mirrors that you like, buy at the store, the ones that hang on the back of the door, and those are really more about like how big the door is, I guess, and then the convenience of the mirror size, seeing yourself in context. But when it comes down to really just seeing a person seeing their entire body from toes to the top of the head, a mirror that's about half the height of a person is all that's necessary. And students will often ask me when we do this one in class, they'll say, yeah, but doesn't it matter how far you are away from the mirror? And no, it doesn't. So you can actually draw this diagram from any angle, and you can see that this is always going to be the case. You're always going to end up with something that's about half the person's height.